Okay, Titans, day before spring break, let's make sure we rock and roll with this stuff. We are on to section 13.4, that is inverse trig functions. That is actually that second button on your calculator. You're going to be using it today. Our goal is to be able to find the angles of right triangles. Using the trig functions, we're going to be given sides and need to find the angles. And then also to find any angle, so angles bigger than 90, using the trig functions. Okay. So those are our two goals today. We'll rock and roll with that. Hopefully a little math joke to get you started there. Someone taking their math test. Find the square root of 225. And of course they're like, oh, I didn't know it was missing. Hilarious. Here we go. Back in section 13.1, we evaluated trig functions of angles and then used them to find sides. And we had just a blast doing that. It was a great time. We use the angles to find the sides, set up our trig ratio, solve, multiply, divide, all those great things. Use our calculator. Now we're going to use sides to find angles of right triangles with trig functions. Okay, so now we're going to use the angles. So let's say I want to find the angle theta if the sine of theta is 0.5. Find angle theta if the sine of theta is 0.5. Well, I remember my special right triangles for that, specifically the 30, 60, 90 triangle. So I'm going to draw that one in there. And we had our 30 degrees and our 60 degrees. Say 30, it was 1, 2, and the square root of 3, not square root of 2 like that last video. So what am I looking for now? I'm looking for the sine. Sine is opposite over hypotenuse, 0.5. Well, 0.5 is equal to 1/2. What do I have here? Oh, 1/2 right there. So if this has got to be opposite in hypotenuse, the sine of what angle is 1/2 or opposite over hypotenuse? Well, that's the angle right here. 1 is opposite of 30. So the angle I'm looking for, or theta, is 30 degrees. I just use that special right triangle to draw it, figure out sine was 0.5, boom, use that, and we get 30 degrees. So just using my special triangle, I knew the sine, I knew the trig function, drew it, and found it. Alright, so that's one way to do it. Another thing, let's look and let's say I want to find the sine of 150, 390, and 510, just using my calculator. Go ahead, see if you can do that. So I'm going to put 150 sine, I get 0.5. 390 sine, I get 0.5. And 510 sine, I get 0.5. So really I got 0.5 for each of those. And we kind of discussed before that anytime I find the sine of those angles, they're all the same because they have the same reference angle. The same reference angle. Okay? So what did I find? They're all the same. And we did that on our warm-up on Wednesday. They are all 0.5. And we're going to figure out how we know that here in a little bit. So the inverse sine of A is sine to the -1 of A equals theta, where sine of theta equals A. So this sine of -1 is kind of where we're looking at here. So the inverse sine of A, which could be like 1/2, 0.25, whatever, is theta. So to find theta, we use the inverse sine. And you'll notice theta will be between -90 and 90. The inverse cosine is the cosine of the -1, which we say is inverse cosine of A, which is theta, where cosine theta equals A. So for example here, if I was to say the cosine of theta equals, let's see, let's see here. Oops, wrong button. Sorry about that, just erased everything on accident. So if I was to say, let's say I said the sine of 30 degrees equals 0.5. Okay, sine of 30 is 0.5. Well, then what that means is if I was to take the inverse sine of 0.5, I would get 30 degrees. So I can use the inverse to find my degrees. That's basically what this is saying. And we can use the inverse cosine, we can use the inverse tangent. And that is just on your calculator. You hit the second button and then the trig function you're looking for. So if I'm looking for inverse sine, I hit the second button and then sine, and it will find it. Okay? Moving on here. Let's evaluate using special triangles for these first three, and then using our calculator to find the angle of the second three. Well, my special right triangles, I'm going to remember what those are, so I'm going to draw those out here. I've got my 45, 45, 90 triangle, which is 1, 1, and the square root of 2. Then I've also got my 60, 30, 60, 90 triangle, which is 1, 2, and the square root of 3. So I'm looking for on this first one the sine, that is the square root of 3 over 2. Square root of 3 over 2. Okay, well, here I've got square root of 3, here I've got 2. I know sine is opposite over hypotenuse, so square root of 3 has to be the opposite, so my angle is going to be 60 degrees right there. I'm just using that right triangle. Where did I find square root of 3 and 2? I found it in the 30, 60, 90 triangle. Square root of 3 has got to be the opposite. It's opposite of 60. Next one asks for the cosine of the square root of 3 over 2. Well, I know cosine is adjacent over hypotenuse. So square root of 3 and 2, I already got those circled, but now we're looking for adjacent over hypotenuse. Well, the square root of 3 is adjacent to 30 degrees. So my answer to this one would be 30 degrees. So the inverse cosine of the square root of 3 over 2 is 30 degrees. The other one asks for the tangent, the inverse tangent of 1. Well, I know 1 is like 1 over 1. Well, where do I have 1 over 1? Oh, here we go in the 45, 45, 90 triangle. 1 over 1. 1 over 1. Tangent is opposite over adjacent. Okay, so where are my opposites and adjacent? Let's just say this one is opposite, this one's adjacent. Which one are those opposite and adjacent to? 45. So that means the inverse tangent of 1 is 45 degrees. Use the number they gave you, figure out which triangle it is, and then compare it with your trig function to the angle you're looking for. Okay, to the angle you're looking for when evaluating using the special triangles. The next three we're going to use just our calculator. So basically this is just calculator work right here. And on your calculator, if you've got the calculators like I have in class, if I want to find the inverse tangent of 0.75, I'm going to put in to my calculator 0.75, that's the number. Notice I don't have any, that's like 3/4. I don't have 3/4 in one of my special triangles. So I'm going to hit 0.75, I'm going to hit second, and then I'm going to hit the tangent button. Remember, if you have the other type of calculators, you hit second, tangent, then 0.75. So I type that in, 0.75, second, tangent, and I get 0.75, second, tangent. I get like 0.64. So the angle is 0.64 degrees. Okay. Then I'm going to try the cosine, the inverse cosine of 0.478. So I'm going to hit 0.478, second, and then the cosine button. So 0.478 second cosine gives me 1.07. 1.07 degrees. Oh, here's my problem. I'm in radians right now. I'm finding it in radians. So hopefully you were getting a different answer and going, what the heck is he doing? We've got to be in degrees. I'm looking for degrees. I got to get my calculator out of radians. So let me try that again. Common mistake. Make sure your calculator's right. I knew those were off. They seemed way too small. So I'm going to go ahead and go 0.75 second and tangent. There we go. I get like 36.9 degrees. That looks a little better for that one. Let's try the next one. 0.478 second cosine gives me about 61.4 degrees. That sounds a lot better. Okay, and then the last one, I'm going to hit 0.98 second sine, and I get like 78.52 degrees. So make sure that calculator is always in degrees first. You want to see the DEG. Okay, don't make that mistake I just did with the radians. Using special triangles, using the calculator. Two different ways to do that here. Alright? Okay, now, here we go. Find the missing angle. So now I'm given a triangle and I want to find the missing angle. Always label your sides. Kind of the key here is always label those sides to decide which trig function to use. So here's my theta I'm looking for, right here. And I've got to compare the sides they gave me. So, well, the side not there would be the opposite. 9 would be my hypotenuse, and 5 is going to be the adjacent side. Okay? Got to know that stuff. If you don't know that right now, you need a little extra practice at home in your own time. So I know the 5 and the 9. So which trig function does A and H go with? Well, I'm going to remember SOHCAHTOA. Oh, that's not a T. SOHCAHTOA. Okay? A and H, that's with the K, the ka. So ka. So cosine of my angle equals adjacent 5 over hypotenuse 9. So the cosine of theta equals 5 over 9. So I'm going to go ahead and take 5 divided by 9 in my calculator. And I get like 0.555 repeating. Okay? So what that means is I need to take the inverse sine of 5/9, or 0.555. So I'm going to put in 0.5555555 second cosine, and I should get about 56.25 degrees. So I just used my triangle, figured out which sides I had, and then used the inverse cosine because I had A and H, adjacent and hypotenuse. Okay? Let's go to and do one more together here. Same idea. Now theta's in a different spot. I've got some different numbers. So theta's here. I've got 7 and 12. Well, compared to theta, this is my opposite. 12 is my hypotenuse. Again, SOHCAHTOA. Which one is O over H? That's the S. So the sine of my angle theta equals 7 divided by 12. So what I have here to find theta, I'm going to take the inverse sine of 7 divided by 12. So on my calculator, here I go. 7 divided by 12. It's 0.583333. And then I'll go second sine. And I get about 35.69 degrees. 35.69 degrees. And I found that missing angle. Technically, I could find the other one because I know that all three angles have to add up to 180, but the question doesn't ask me to do that, just asks me to find this one. Okay? Figure out the sides you have. What are they compared to your angle? And then which trig function to use. Alright. Here's another one. Go ahead, pause the video right now. See if you can do this one, maybe with the person next to you on your own. Take about a minute, minute and a half, see if you can go. Alright, hopefully we're back now. So we're thinking theta here. How do they compare to theta? This is opposite. This is adjacent. Which trig function has opposite adjacent? TOA, tangent. So tangent of theta equals 8 over 9. So the inverse tangent of 8 divided by 9 is what? On my calculator, 8 divided by 9. Second tangent. I get 41.6 degrees, 41.63 if you go one farther. 41.6 degrees. Alrighty. Last couple things here. So now we use just a right triangle. Now what we're going to do is we're going to find any angle. So in a right triangle, they're all less than 90. They're an acute angle. Now we're going to have to look at any angle in any quadrant. So, for example here, this question here says, solve the equation, the sine of theta equals 0.25, negative 0.25, where theta is between 180 and 270. 180 and 270, what does that mean? Let's take a look.